Okay, good morning, class. Kalau semua prefer online kita pakai. Saya jalankan online pada jalan. Kalau sini. Okay, today we continue with the application of this integration of factor value function. Okay, so today we will look at this arc length. Okay, arc length refers to the length of an arc. Okay, so the formula of the arc length, okay, is actually this one. Okay, we will use this formula. But how to get this formula? Okay, I will explain step by step. Okay, this one I want to show on the board first. Okay, can you hear what I say? Even with this noise, can you hear those from the back? Okay. Okay, now let's say this is an arc, RT, and this is the 2 points C and D. And now we want to find for the length from this C up to the D. Okay, how is the long? What is the length of the arc? Okay, so to get the length of arc, we will break this into many subintervals. Okay, many subintervals. Yeah, and each of these intervals, let's say this is P. Okay, starting from this P, Pi plus 1, Pi plus 2, up to maybe P infinity. If we break this small enough, then we may get until P infinity. Because if you let's say we want to get the length. If we just break this into 2, we will use the length. Okay, we will calculate the length between any 2 points and we sum them up. So compared to this one, okay, this it will give less error. The error will be lesser. Okay, especially when you see the point. Let's say we want to find the length from this point. Let's say B to C. So if we have only 2, that means this one. Okay, we sum up the length of the 2 points. Okay, P1, P2, P3. Okay, we sum up the P1, P2 length and the P2 to P3 length. Compared to if we break this into infinitely subintervals and we sum up the length, and this will give us a better approximation, right? So that's why our length, okay, the arc length L, okay, is given by this limit n tends to infinity. Okay, we want to break the distance into P subintervals. Infinity subintervals. So with the length, it will be the summation. We will sum up. Okay, we will sum up the P minus 1 Pi. We will sum up the distance for 2 P. Okay, then it will make up the length, the arc length. Okay, so from here, the distance. Okay, we refer back to the slide. Okay, this one. The summation of the distance of all the P's. And we all know that the formula for distance in between 2 points is given by this one, right? To get the distance in between 2 points, we will find the distance between x, we square it, and then we find the distance between y, we square it, and we sum them up in the square root. This is a formula to get the distance between 2 points. Okay, this one. Okay, so now let's say this xi minus xi minus 1. This is the changes on x. So we change this into delta x. Delta x means changes in x. And delta y is the changes in y. Okay, then we get this. Okay, next, if we factorize the delta x, suppose you have this delta x squared plus delta y squared. So now we factorize the delta x squared. Delta x squared. Okay, factorize. So what we have is 1. 1 plus delta y squared over delta x squared. Right? You see, when you multiply this into this one times 1, you get this. This one times this, you cancel out this 2, you get delta y squared. Okay, you factorize this one. And we know that sub AB equals to sub A sub B. Okay, we can break this into this. So we set this one, we can break it into this one square and this one square. Okay, we can break it into this. And next, we can cancel out the square root of this square. So this is how we get this. 1 plus delta y over delta x squared. Okay, this is how we change. This is how we change this into this. From this into this, factorize this one, and then we separate this into 2 like this. Then simplify, we get this. Okay. Now, based on the definite integral definition, okay, this is actually equals to the integration of this one with respect to x. When this delta x close to 0, okay, when this delta x close to 0, this, okay, this one, limit n tends to infinity, summation of this, it will be changed into this one by definite integral definition. So that's why we get this. Okay, we change the delta x into dx. Okay, here the delta x will be this dx. And here we have delta y over delta x squared. Okay, so we are integrating from a point to another point. Okay, so now we have this formula. And this formula is actually used when you are given an r, which is displayed in y in terms of x. Okay, if y in terms of x, we will use this formula. But your r is given in a parametric form, r in t, where your x, y, f, g, h is in terms of t. So we don't use this formula. We have to further derive this formula into the one with t. So next, what we do, we multiply find a dt over dt to this. Okay. Okay. So this one we want to change into dt. So we multiply the dt over dt, where we do not change this thing. Okay, we do not change this one, because after you cancel dt, you still have this. Okay, so this one. Okay, we give this over dt to this. Okay, we move the 1 over dt to here. So you have this. Then we have a dt here. And now we want to combine this into this square root. So if you want to put this into the square root, you have to square this one and then put a square root, right? You have to do this. So that after you cancel the square root with the square root with the square, you still have ext. We do not change anything. We just want to combine this into here. Okay, next. Sub A times sub B equals to sub A times B. Okay, this is your A. This is your B. So this one multiplied to you have this plus this one multiplied to this, you can cancel the dx squared. Then you have dy over dt squared. And then this is. Okay, this one multiplied to 1, you get this. This one multiplied to this, you can cancel out the dx squared. So this one will be combined with this dy over dt squared. This one also dt squared. Okay, dy squared over dt squared. Then we get this. So this is the formula where we can use, but this is for two-dimensional. Two-dimensional, that means if your curve is 2-dimensional, we can use this. Okay. But if your curve is in 3-dimensional, we will have one more term plus the dz over dt squared. But we don't use x, y, z here because our component function is f, g, h, right? Okay. So we use, this is for 3-dimensional. 3-dimensional, then we have f prime, df over dt. But sorry, this is dt. This is dt. For 3-dimensional, we use FGH instead of x, y, z. Okay, FGH. So df over dt, we write it as f prime. Okay, df over dt plus g prime square plus h prime square dt. Okay. If your curve if R is in 3-dimensional, we will use this formula to compute for the R length. But if you look at this formula, what is this represent? This is actually the formula for the magnitude of R prime, right? Magnitude of R prime. Because your R is FGH. Your R is FGH. So your R prime will be F prime, G prime, H prime in terms of T. Okay, in terms of T. So when we find for the magnitude, we will square each of the component functions and we sum them up in the square root. So this is what we have. So this is actually the magnitude of R prime. So we will use this formula to compute for the arc length. Okay, we will use this formula to compute for the arc length. This formula, I'm not sure whether it is included in the appendix. Okay, you can find from the past year question. I think the appendix is the same in the past year. Okay, I'm not sure whether this is included in the appendix. Okay, if this is not included, that means you have to know how to find for the arc length. This is the formula. Okay, now we look at the first example. Find the arc length of this for t from -1 to 2. Okay, so to get the arc length, we have to compute for the magnitude of r prime. So we have to find for the r prime first. Okay, so you differentiate these three functions with respect to t, then you get these three. Okay, differentiate this one, you get t. Differentiate this one, you get 2 times t. Differentiate 2t, you get 2. Okay, then find for the magnitude. Okay, you square this, square this, square this, and sum them up in the square root. Simplify, factorize, you get this t plus 2. Okay, then we will put this into the formula. Okay, the arc length, it will be, you are integrating t plus 2 with respect to t from -1 to 2. Okay, from -1 to 2. Okay, now I want to explain a little bit on the arc length from a point to a point. Okay, from this example, t from -1 to 2. Okay, t from -1 to 2. Meaning that we want to know what is the length from this point to this point. Okay, we want to calculate the length from this t equals to -1 to t equals to 2. Your arc is half t squared 4/3 t 3/2 and 2t. Okay, this one, when let's say when t equals to 0, okay, when t equals to 0, when t is 0, 0, 0, 0. This means at this point, you have this point, 0, 0, 0. We just need to substitute the corresponding t value into your arc, and you will get the point. Okay, so -1, when you substitute -1, you will get a point. So sometimes the question, it will give you t from a value to a value, then you just use that value. But if the question is give you from one point to another point, you have to find for the corresponding t value before you do the integration. Now back to this. Okay, just now we obtained t plus 2. So we put this into the formula t plus 2. Integrate from -1 to 2 with respect to t. Okay, so t, when you integrate, you get t squared over 2. 2, you get a 2t, and then you need to substitute these values. Okay, first, you will put this 2 into t first. Okay, so 2 squared, you get a 4. 4, simplify, you get 2, this one. And then plus 2, substitute into this t, you get 4. Okay, then minus the substitution of -1 to this t, you get this. Okay, then you just solve, you get this figure. This figure represents the length from this point to this point on this arc. Okay. Any questions?
Yeah, okay. So,
Yeah. No. If the question gives you the value of t, you just use the value directly. But if you are given something like this, you are given point, and then you need to find for the corresponding t, because according to the formula, we need this value a and b. This is not point, this is the value of t corresponding point from the corresponding point. Okay, now we're back to the, okay, this one, okay, we look at the second example. Okay, this is the previous example. So here, we will get an r prime first. Okay, differentiate with respect to t, and then we compute for the magnitude. Okay, you square every single component functions and you sum them up in the square root. Simplify, you get 5. Okay, now you get 5, meaning that we will integrate this 5 from 1 up to 2 with respect to t. Okay, this is important. Okay, this is important. You have to know how to come up with this one. Okay, this is from r magnitude of r prime. Okay, this is the starting point. This is the ending point on the arc. Okay, any questions for this one? Okay, so this one you just need to substitute. Substitute 2 into t, 10 minus 1. Minus 1. 5t. This one should be 5. Multiply 4.
Okay.
Yeah, this one should be 5. Okay. And okay, next example. You are not given the t values, you are given the points. So from here, we have to identify the value of t that represent this point and another t value that represent this point. Okay, so for this first point, how to identify the t values, we will equal the first component function to 0, the second component function to 0, and the third component function equals to 0, and you solve for these 3 equations for the t value. So from here, we know that t is 0. This one also t equals to 0. This also t equals to 0. That means t is 0 for this point. Okay, and for the second point, we equal the first component function to 8, the second component function to this 32/3, and the third component function equals to the 8. And you solve for these 3 equations. Okay, then you get the t equals to 4. So t equals to 4 represents the point of base on this arc. Okay, so later on we need to integrate from 0 up to 4. Okay, 0 up to 4. Here, 0 up to 4. And this is taken from the previous example where the magnitude is already found, which is t plus 2. Okay, so we just integrate t plus 2 from 0 up to 4. Okay, So t, you get t squared over 2. 2, you get 2t. Okay, 4, substitute into here. And here, you get this. Minus 0, substitute into here, you get 0. So you get 16. Okay, any question? Do you understand this? We are finding for the arc length. We are finding for the arc length, but t value is not even, you are given the point. That's why we need to identify the t value that represent that point. Okay, so how to identify the t value? We just equal the first component function to the first value, second to the second, third to the third. And find out what is the t value. Okay, that t value, this t value, it must be satisfying all three. 0. When you substitute 0 into here, you will get 0. 4, when you substitute 4 into here, you will get this point. This is their corresponding point. Okay. Okay. Next. Okay, when you are given the starting and ending point, we know where to start and where to stop. But if you are given only the starting point, okay, let's say T0, T0 is the starting point, but we do not know where to stop. It doesn't let you know where to stop. Then what we found will be a function in T. Your arc length will be a function in T. For example, T squared plus 2. Okay, your answer will be a function in T. And once you get this arc length function, let's say I want to stop at 2. Then when you substitute 2 into here, you will get 6. That means the length from this point up to this is 6 units. If you substitute t equals to 3, the ending point, let's say, is 3. So you substitute 3. So you get 11 units from this starting point up to this point. Okay, so this represents the arc length function. Okay, this is different from the previous example because the previous example, you know where to stop. If you know where to stop, of course, what we get will be a value. Okay, it will be a value. But if you're not given the information on where to stop, then we will get a function. We will get an arc length function instead of a value. Okay, because this is a variable. This will be in variable. T can be anything. Okay, and also, okay, let's say this t equals to 0 is 0. So we are integrating from 0 up to t because we do not know where to stop. So we will integrate up to t. And for this r prime t dt. But this one, we don't use t. We don't use t, we use a symbol of tau. This is a Greek symbol. Tau. We don't use t because let's say you are integrating from 0 up to t, and your function is, let's say, the t plus 2 just now. So what do you get? You get square over 2 plus 2t, right? And then 0 up to t. And instead, we are substituting the t into t. Okay, in mathematics, we don't say t, substitute into t. So we will change the t into tau. That means this one we will change into tau. This will be tau. This will be tau. So we will substitute t into tau. Okay, just because in a proper mathematical equation, we don't substitute t into t. Okay, that is the only reason why we use this tau instead of t, because we have a t here. Later on, we want to substitute t into the tau. Okay, so if you are given only the information on the starting point, we will use this formula. Okay, starting point not necessary to be 0. This is T naught. Okay, this is T naught. Okay, so we will use this formula for this kind of case. Okay, now you can look at this example. Find the arc length function of this arc from the point this. So you are given a starting point, okay, only a starting point. Okay, this is also a reference point, okay, reference point. So this one, we will identify the corresponding t value. Okay, and the corresponding t value is 0. Okay, t equals to 0 to get this point. So we will integrate from 0 up to t. Okay, and from this r, we need to find what the r prime. Differentiate this with respect to t, you get this. And we find what the magnitude. Okay, magnitude simplify, you get this function. Okay, so we will integrate this function, okay, this function, but we will change the t into tau. Okay, we change the t into tau before you do the integration. Okay, and we are integrating with respect to tau. Okay, e tau, we get e tau. 1, we get tau. So t substitute into tau, we get et plus t. And then minus 0, substitute tau, e0 is 1. So this is the arc length function, where this is the starting point. Do you understand this? Do you understand this? A bit. So which one that you do not understand? Which part? Which part? This one? This one, you know how to find, right? You all know how to get up to the magnitude of the RT, right? R prime. Then implies. Okay, implies. This is same as the previous example. Same as this one. We want to get what is the corresponding t value. Because you are given a point. You are given a point. So we will let this et equals to 1. 2 sub 2 et over 2 equals to 2 sub 2. T equals to 0. Then you solve for this. Okay, when you solve this, t equals to 0 because e0 is 1. Okay, so from here, t is 0. Then this one, you cancel out the 2 sub 2 with the 2 sub 2. You get 1, right? E t over 2 equals to 1. So when t is 0, you get 1. So when you solve this, you get t equals to 0. And from here, also t equals to 0. Meaning that from these 3 equations, when you solve all 3 equations, you get t equals to 0. So the 0 represents this point. T equals to 0 represents this point. Okay, same with the previous example. When you are given a point, you have to find what the t value. Because we are integrating this one, this is the t value, not the point of this FGH. Not the point of FGH. We have to find the t value that represents this particular point. Okay, the first one, ET equals to 1, right? Okay. Non-ET equals to 1. Non-ET equals to T. Log 1 is 0. When is the ET equals to 0? The T must be 0, right? Sorry, when is the ET equals to 1? The T must be 0 because E to the power of 0 is 1. So we know that T equals to 0. The second one is also similar. 2 sub 2. 2 sub 2 ET over 2. E over 2 equals to 2 sub 2. So when you cancel out the 2 sub 2, you get ET over 2 equals to 1. Log ET over 2 equals to log 1. So log ET over 2, you get T over 2. Log 1 is 0, so T is 0. Okay, and the last one is T equals to 0. So that's mean from the last one is T equals 0. That's mean from these three equations, we get T equals to 0. So the T naught is 0. Okay. Okay, so do you understand this now?
Yes.
Okay, now we look at the next example. Okay, find T such that the length starting point is 6 pi. What does this mean? The starting point is 0, 0, 2. Okay, from the starting point up to a certain point, the length is 6 pi. So what is the ending point? This is the question 1. What is the ending point? In such a way, starting point is this one, and starting from this 0, 0, 2 up, the length is 6 pi. So which is the what is the ending point? So then the length is 6 pi. This is what it means. So this length, okay, the length we use this formula because we have only the starting point. So we use this formula, and the length is given as 6 pi. Okay, so still you have to find for the R prime. So differentiate this with respect to T, get this, and then find for the magnitude. Okay, after simplify, you get 3. So from this point, 0, 0, 2, okay, so you equal the first to 0, the second to 0, the third to 2. Okay, so you solve these 3. So from here, T is 0. Okay, from this one, sine T equals to 0. So your T can be 0, can be 2 pi, can be 4 pi, and so on. And this one, after you cancel out the 2, your cos T is 1. Cos T is 1, that means your T can be 0, can be 2 pi, can be 4 pi. So the T value, it must satisfy all three equations. So from the first one, you have only T equals to 0. So of course, the value that represent these 3, it will be 0 only. Yeah, because this gives only T equals to 0. This gives T equals to 0, 2 pi, 4 pi, and so on. This also 0, 2 pi, 4 pi, and so on. But because of this one, it gives only t equals to 0. So it must be 0. We must choose the value that satisfies all three equations. Okay, it must satisfy all three equations. Okay, and first, okay, so we are integrating from 0 up to t. Okay, and we are integrating 3 with respect to tau. Okay, so 3, we get 3 tau, and when you substitute t into tau, you get 3t minus 0, which is 3t. Okay, this is your length. Your length is 3t. And the given length is 6 pi. So you just equal the 3t to the 6 pi. Then you will get what is the value of t. So t equals to 2 pi is the ending point. Okay, and if the question wants you to give what is the point, what is the ending point, then after you get this, you have to substitute this into the t to get the corresponding point as the final answer. Here we find up to t only because here we just need to find t. But if the question wants you to identify the point, what is the point in such a way the length of the arc from this point is 6 pi, then you have to work out the same procedure to get the t value first, then you substitute the t value back into the arc to get the corresponding point as the final answer. If you look at the past year question, you will know what I mean. Okay, now we try this exercise. You need to find for the r prime and magnitude of r prime, then find for the length. Okay, try first. All the small places. Okay, any questions for number 1A? Okay, t is given 0 to 1. Okay, the ijk, we have two ways to represent the vector value function. It's either in the form of ijk. If you use ijk, this means this is in the linear combination in a class. Or you can present the vector into this, the one with bracket. They are the same.
Yeah.
Okay, factorization. E2t is ET times ET. You get E2t, 1. E negative 2t is E negative t times E negative t. Okay, plus either plus plus or minus minus, but because of this is plus, so this is plus. So ET times E negative t, what again? Yes, 0. You get 0, take 0. E0, right? E0 is 1. E0 is 1. So the answer get 2. So you can factorize this into this 1 times this. So this is EP plus E negative E squared. Then you cancel out the square root of the square, you get ET plus E negative T. Okay, so your outlet is you are integrating from 0 up to 1 for this equation, for this function, sorry. The T is not in sense. What do you do? Is when substitute E and E. It's when okay, so ET, you get ET. E negative T, you get minus E negative T because you need to over negative 1. Okay, when you are integrating this one, you get E negative T over negative 1. So you get this 0 to 1. Okay, substitute the 1 into t, you get E1 minus E negative 1 minus 0 into t, you get 1 minus 1. Okay, so you have E minus E negative 1 as the final answer. Anyone have a sign by minus? Surya, are you do the talking now, Surya? Because I saw your Surya. Okay, any questions, Bobby? Okay, now we look at number 2. Number 2, find the arc length from a given point to another point. Okay, so now we want to factorize. So 4t squared, 4t squared, can have 2t times 2t. 1/4, we can have 1/2 times 1/2. Okay, plus, plus. So when you multiply 2t to half, you get a t. When you sum up, you get a 2t, which is this one. Okay, so we can factorize this into 2t plus half. When cancel out the square with the square root, we have 2t plus half. Okay, next one, we have to find the corresponding t value for the first point. Okay, so for this point, we will let t squared equals to 1. The second function, 2 sub 2 over 3, t to the power of 3 over 2 equals to the second value. Then the half t equals to the half. Okay, so when you stop this, the first one, you get a plus minus 1. Okay, this one, after you cancel out this, you get a t to the power of 3 over 2 equals to 1. So t is 1 to the power of 2 over 3, which is 1. And this t is 1. So plus minus 1, 1, 1. That means your t must be 1. It goes to the second point. Okay, so the starting point is 1, ending point is 9, and we can proceed to integrate this one from 1 to 9 respectively. Okay. So your length will be from 1 to 9, 2t plus half, respect to t. Okay, so you have b squared plus half b 1 to 9. Okay. Any question for number 2? Can I wrap this up? Huh? Yeah? Okay, for question number 3, you are given the starting point. Okay, so you need to compute for the R prime first, then the magnitude of R prime. Okay, then find for the t value of this point. Factorization. 40 squared, we have 2t times 2t And the 9, you have 3 times 3. So you get a 6e, 6e, total 12t. Okay, after this 12t. So you have 50 plus 3. Well, and then from the starting point, you let the first component function to be 1, the second component function to be 2 over 3 as well, and 3t equals to 3. Okay. Okay, so t naught is 1. T naught is 1. So the naught length, we are integrating from 1 to t. From 1 to t, and we are integrating. Okay, this is 2t plus 3. 2t plus 3. So this is 2 tau plus 3. T tau. Change the t to tau. Okay. And when you do the integration, you get a tau squared plus 3 tau from 1 to t. Okay. When you substitute the t into the tau, you get t squared plus 3t minus 1 plus 3. Okay, so that's be t squared plus 3t minus 4. Okay, any questions? Okay, so number 3 done. Okay, integration respect to tau, you get a 3 tau, 3t minus 0, which is 3t. Okay, so your arc length is 3t and the given length is 3 pi. So you just need to equals your length to the given length to get the t. Okay, any questions? Okay, the last part, motion along a curve. Okay, motion along a curve is for two-dimensional vector matrix function, and the motion in space is for three-dimensional. So you see this one is two-dimensional. So if position vector, you just need to differentiate your position vector to get the velocity vector. Okay, and when you differentiate the velocity vector, you will get the acceleration vector. And to get the speed, you just need to find for the magnitude of velocity. Okay, the velocity is the speed. Okay, so when you are given the position vector, you differentiate to get velocity and acceleration. And if you are given the acceleration function, that means you need to integrate to get the velocity and integrate to get the position vector. We look at the first example. Okay, you are given the position vector and we want to find for the velocity and speed. Okay, this is straightforward. We just need to differentiate this with respect to t to get the velocity vector. Then find for the magnitude of this. This is the speed. Okay. Now find the acceleration given the position vector. Okay, so position vector, you just need to differentiate one time, you get velocity, and differentiate velocity, you get the acceleration. Okay, so far, okay? Okay, now we look at the motion along a curve. Okay, okay, this one, given a velocity vector, okay, you are given a velocity vector, and we want to find what the position vector, meaning that we have to integrate. We have to integrate the velocity to get the position vector, and you are given an initial position. Okay, so now we integrate the velocity vector to get the position vector. So when you are integrating the t, with respect to t, you get t squared over 2. Okay, plus 1. Plus 1, you get a plus t. And then you get a plus c1. Okay, plus c1 because there is no limit given here. And then t squared, after you integrate, you get a t cubed over 3 plus another constant, which is c2. Okay, now you are given this. You are given the r0. Okay, this is your r. This is your r now. So when you substitute 0 into t, okay, into this t, you get c1, comma 0 plus c2. Okay, you get only c1 and c2 when you substitute 0 into here. Okay, substitute 0 into t, you get c1, c2. And given that r0 equals to 1 and negative 1. So from here, this is your r naught. Okay, this is your r0. This is the r0 given by the question. So from here, we know that our c1 is 1, c2 is negative 1. Okay, then you just substitute the c1 and c2 back into here, and here you will get your RT. Okay, the complete RT. Okay. Okay, motion in space, this is for 3D. Okay, actually, this is still the motion of curve one. This is in 2D. Okay, so this is the concept is the same, whether 2D or 3D. With position vector, and you differentiate it one time, you get velocity. Differentiate one more time, you get acceleration. And the magnitude of the velocity, it will be speed. Okay, the concept is still the same. No. This one you have to know. Position vector, when you differentiate, you get velocity. When you differentiate velocity, you get acceleration. Okay, then Find the velocity and speed. Okay, this one is straightforward. You are given position vector, and we just need to differentiate one time to get the speed, and we find what the magnitude of the velocity to get the speed. Okay, this one is straightforward. Find the acceleration. Okay, this one also straightforward. We need to find the acceleration from a position vector. So given the position vector, you differentiate one time, you get r prime. This is the velocity. Differentiate velocity, you get the acceleration. Okay, as long as you know how to do the differentiation, this one shouldn't be a problem. Okay, now we look at this exercise. Find the acceleration when you are given the position vector. Okay, so you just need to differentiate this twice to get the acceleration. Okay. For number 2, you are given the acceleration. We want to find for the velocity and position vector. So we need to do the integration. To get the velocity, we integrate the acceleration. Okay, we integrate the expression. The next one, you get t, right? Integrate 1, you get t. T, c1. Then this one, you get a t squared over 2 plus c2. Then you compute for the v0. You compute your v0. So when t is 0, you get 0 plus c1, which is c1. 0 plus c2, which is c2. And the given v0 is 2, -1. Okay, your v0 is c1, c2. The given v0 is 2, -1. The meaning that this v0 equals to this 2, -1. Okay, that means c1 is 2, c2 is -1. Then you put this c1, c2 back into here to get your vt. Okay, so your vt will be p plus c1. P squared over 2 plus c2. So this is your vt. Then you do the same, you integrate this to get the coefficient factor. Okay, integrate t plus 2. Okay, I use d. I use d because c is used here. So I use d. T squared over 2. That's been t cubed over 6 minus t plus b2. and your R0, because you are given this R0. So you can substitute T by 0. When T is 0, 0, you have D1. 0, 0, you have D2. And your R0 is the same with this 0, 8. Okay, that means D1 is 0, D2 is 8. Okay, so you just substitute the D1 and D2 back into here to get your RC. Just a constant, because C is already used here, so I use D here. Okay. Okay. Yes, constant, but a different constant. Yeah, integrate. Okay, after you integrate, you substitute 0 into T. Okay, so this one E0 is 1, -1. -1 plus C2. Okay, this is 0 plus C3. And your V0 is the same with this 0, 0, 1. So from here, you can get your C1, C2, and C3 to complete the VT. Okay, so C1 is 0, C2 is 1, C3 is also 1. Okay, so integrate the V, you get R. Okay, T squared over 2, you get a T cubed over 6 plus E1. This one, you get a T plus E negative T plus B2. E2 plus B plus B3. Okay, then you find for the R0. Okay, R0. So you substitute T by 0. So you get an E1. 0 plus E0 is 1. 0, 0, D3. And this is same with the given R0, which is 4, 0, 0. Okay, so that means your D1 is 4. D2 is negative 1, D3 is 0. Okay, and hence you can get your RT. Okay, so you substitute your D1, D2, D3 into your RT. Okay. Any questions? We have done the syllabus of week 13. So in the next class, we will start the syllabus of week 14. Okay, so if there are no more questions, then we will end the class here.